All right, and we are live. So click some buttons. Okay, it's pretty good. We're gonna change what we're doing today a little bit, and I'm gonna explain what that means. So, if you look back at the previous streams that we had, I had focused on the first stream on a specific system in the game, which is going to be a terrain generation system, and I tried to make that work. Then I realized, well, hang on a minute, that's not what the game is about, though. And so the reason why I thought that is because I watched Game Maker's Toolkit on it's this video. I actually have to find it now. Let me quickly open YouTube. Uh, 1 second. So the game, oh sorry, the video was, let's see, GMTK, a mistake, every dev makes. That should find it. Oh, lag. I think I'm gonna have to like click this and close this entire thing because this is lag. Okay, go bye. Okay, that should be a little better. Uh, yeah, I mean it is. 1 second, let me make sure there's less lag. Yeah, this one. So in this video, uh, I'm not actually gonna
Last time on developing, I picked my game engine, Unity.
stop. So in this video, he covers that if you are making a game, then you should start from a prototype. And I think about somewhere, I don't remember where, like somewhere at the end, I think. I don't remember. So like somewhere in the end, he showed some pretty interesting footage of a prototype, which looks actually like a prototype. Where is this thing? I want to show you what a prototype looks like. I mean, it will look like this probably. Where in the world is it? Okay, anyway. So, we need to start with the prototype. And the prototype means we need to somehow make um, make something small that represents the gist of the game. And the actual idea for the game was, okay, it's a sandbox, but I want to add NPCs to it. And if we're talking about NPCs, well, then we're gonna need, well, the AI, but the AI isn't really the scope. We need to do something else instead. Let's make some dumb AI. Okay, let's make them not walk, let's just make them stand out there and just shoot. But this AI, like, there should be enemies, and there should be your friendly AI, and there should be neutral AI as well. And so I want to kind of work on that today. I want to make, I want to think of like, what might we need? Um, like what could be the thing that we're gonna need for the AI? So I'm gonna kind of scrap all of this because I mean this is not really. Um, Actually, no. Wait, this is the thing that renders the game. So we're not gonna use main.cpp today. We're gonna write tests, and because I was playing around here, I'm gonna delete some of these files. In fact, can I like just open Dired? This is gonna be a little faster. DDD, and this as well. And what else? Yeah, okay, X. Yes. All right. Maybe, maybe. Is this maggot? That probably is maggot. Showing something, I don't know. Let's see. What might we need? Let's just make sure our include. Okay, include is okay. Um, build. Okay. Let me just go through these just to make sure there's no junk in there. Okay, tests. It's just a setup for tests. Okay, main.cpp. I mean, the main.cpp is not really required right now. So I would go as far as just clearing it out, but because, I mean, I don't know. Let's see. Let's just write a comment here. In fact, you know what? Let's clear it out. Let's just clear it out completely. Like, let's just get rid of everything in here because this is not required right now. We don't need our main.cpp to do anything really. So let's get rid of this. That, just everything, okay? There's gonna be nothing in this thing. It's just the bare minimum to make this thing compile. Okay, so we've done that. Let's make sure we can compile with the dash dash build. There you go. We have no tests, so I actually don't know why it doesn't run the test, even though it should. Let me make sure. Add custom command. Maybe it's because it's not rebuilding the test executable. Yeah, that's why it doesn't run it. hmm So that's efficient. That's pretty cool. So now let's actually build something. And for this, we're going to go into tests, and I need to think of like how would I structure my project. And not really sure. How would I structure a how to structure ECS game project files. I'm getting as much keywords out there so that I get as much stuff. What did I press? No, no, go back. Open new tab. Maybe. Oh, yeah. This Reddit post would be probably interesting to look at. Let's say game dev file structure. Um, code. Oh, nice. So, yeah, he is. In Xcode, I organize them like this. Okay. Tools, shared. This is pretty much core. Into these components, UI audio, log, utilities, preload, assets, level at Swift, blah 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 blah. Okay, assets don't really care about that. The rest, conclusion. Okay, so they just like do this, and then inside, I guess you put whatever you want. Let's look at this here. Okay, I'm currently creating, blah blah blah. Put aside distracting thoughts of managers and objects containing things. They have their issues, but not as a foundation, and certainly not for ECS. In your description, I see many warning signs of an OOP background, which is going to take time to grow from. Unfortunately, I work with people who have taken a year or more to get it. Components, as usual with paradigms, it's easy once your brain is acclimated. Parental dynamics seems impenetrable and technically understandable. You just have to feel for it. Okay, the essentials. Entities are only an ID, not an object. Components are properties which... Why does he have... That first thing had like a components. Uh, or did it have entities folder? Did I see a entity? Why is there an entity folder? It's not ECS. Okay, back to this. Components are properties which with wait. well, which things entities can optionally have. Functionality is ideally realized by processing component-wise, e.g., render all render components, or processing perceiver and perceivable without any care whether a perceiver happens to have a security camera, a soldier, or the moon. Okay. Okay. In practice, ability table would be enough for many cases. You want to join each other things with. Oh wait, this is about, I guess, the engine. Yeah, they're making an engine. That's not really. Okay. And here, scenes, common. Okay. But this is not. Is this from Unity? No, let's close this immediately. I'm not. No. I just no. I don't want to get into that. I just not gonna make sense for me. Okay. Do we get the folder structure? I need the folder structure. Like, how do you structure things? Because I understand, yes, you put components in one folder and you put systems in another folder, but it's not just that. It's like, okay, let's say we have like the game, but the game has the game menu, which would have, say, components for some buttons, and those buttons may be like really weird kinds of buttons, and we're gonna have a menu, sorry, the actual game world, and in the game world we might not need all the components and all the entities. Sorry, actually entities, they're all the same, but we're not gonna need like all the systems and all the components. We're just gonna need like a subset of them. So I don't know, maybe Wikipedia will tell me. Microsoft. The Microsoft Docs are hard to read. Part of the reason is just if you open this page, like it's just gonna be like, look at the amount of stuff that's happening around it. Like I hope this is the one example that I'm. One sec, let it load. Okay, yeah, like okay, well this one's good. They removed the sidebar. That's pretty good. All projects, name, category, subcategory. What is up with this category? Like, wait. Oh. Oh. What the? No, this is just digital. Okay, this is archival organization. Let me see. Maybe characteristics. We know that. Any? No. Okay, we're not. We couldn't read through the. Actually, let's read through here real quick. You know what? Because we're gonna develop a prototype, I don't think it matters as much. And the messier we make it, the better it is because we're gonna find a bunch of insight on how to not to structure it. So let's do that right now. Let's just make a mess, but we're gonna try to make an organized mess so we can recover from it later. So if we look at the tests, um, this tests folder is pretty much SRC, but it's not SRC. That's the only difference. So when we're thinking about the structure of the project, we start with the test folder. In fact, you know what? I want to rename this to test. To be honest, doesn't really matter. We can rename it later because it's not gonna, like, nothing depends on test. Okay. So in the test folder, we make the same structure as our project folder. So the first one that I'm gonna make, the first directory, uh, is gonna be system. System, that's gonna be the directory, and hit R for refresh. And inside of here, we're gonna need to create a file. And this first file, well, I mean our game is let me open my Scratch document, which is just a document I use for all that stuff. So this thing will have AI slash NPC characters. Okay, so with this thing right here, we are going, how do I close you? Can't close you like that. Let's just do escape, please. Space OP. Okay, there you go. So AI NPC. So this one is going to have. Why is this like uh, double? Like, let's do this way. Oh, it's like some features that I want. I mean, that's kind of a lot of stars to type. In fact, you know what? Let's just make this, and then this can have one less stars. I just don't want to type like triple trillion stars just to make like a subtitle, because we this way we need 2 stars for a subtitle. And the way I had it before was 3 stars, so it's just too much for me. Too much to ask. So let's get rid of these. Let's put them spaced out. Okay, so back to this. So AI, we're gonna have friendly and enemy and neutral. These are gonna be the 3 types of NPC. And the first type, the friendly, we're actually not gonna start with these. We're gonna start with the enemy because these are the interesting ones. These are the ones that we can interact with. So they are gonna be in groups or like more like gangs. Um, I'm just kind of like, what is it called? Forgot the word. I forgot the word. Brainstorming, I think, yeah. I think that's the word. So I'm just piling ideas in there. So they're gonna be in groups and gangs. They're gonna be armed. They're gonna be hostile to the player. They're gonna be. What are they gonna do? Let's think about it. Um, they are gonna have some. I know. I'm gonna get rid of this first part. So, defend some territory. I think that would be kind of the gist of it. And every like group of NPCs, and maybe even like smaller groups, they will have uh, in like a village, basically. So they're gonna build a settlement where they live, and then they might have some remote locations that they go to, but that's not really what we're gonna be trying to emulate here. Okay, so that's done. That's it. And I'm kind of thinking about something. I'm thinking about like um, should the game be like should the coordinate system be like the old Game Boy Pokemon, where it's aligned to a grid of like one block or like one square. So you cannot move like zero point 0.5 blocks or zero point 0.1 blocks or like tiles. You need to move like exactly one tile. I think this is what we'll end up doing, because I'm not really willing to build like this thing where you have this physics system where the player can move freely. The reason why I'm not willing to build that is because I don't see the benefit. It's not gonna benefit the style of the game. It's gonna be a pixel art game. It's supposed to be like this retro style thing. I don't see a point in making it uh, this style of like you being able to move like a pixel or like half a pixel or something. Like it just that doesn't make sense. Although we might do it later. We might do it later. I mean, it's not really that hard to implement some kind of like collision system later. I mean, and the cool thing about ECS is that you can just slap new stuff on there, and you can then disable those new things. So we're gonna just kind of get going. So that's the enemies. Let's implement them. So I will need to probably somehow get this onto like a sticky or something. I guess we could put it in the scratch buffer. Nah, let's just, you know what? Let's leave it open like this. Did I save this? Yeah, I did save this thing. Okay, pretty good. So let's go over to System, and we will need components, but components live under include. So if we unwrap this thing, we see there's some stuff in here, but we are going to create directory called components. There you go. Refresh to get this directory. And under here, we're not really going to create anything yet because we first create the system in the test, then if we need some component, we add it in. This is a different approach to how a lot of people think. They think, okay, I'm gonna need this and that and that, and they add stuff that's not really required for the functioning system. Instead, what you do in test-driven development, and the reason why I'm going to implement test-driven development is because this is the only way I'm going to go past the prototype phase, and even the prototype will just fall apart at some point if I don't implement TDD. So I'm going to go ahead and just actually let me bump down my mic a little bit. Okay, that's going to be a little bit. Let's see. This should be okay. Okay, I just left it where it is. Um, okay, I'll leave it there. So I'm not even sure if you can pick it up, but like I feel like this lower setting is gonna be a little better on the recording. So under system, we need to create a file. And this file, I mean, this is the hardest part about creating this file. So let's create this file called, let's say, so we have our enemy. And the first thing that I think we should do is we should make the enemy be able to move around. I just want just an enemy be able to move around. So it's going to be movement dot cpp. There you go. Movement dot cpp. Refresh, open it up. There you go. So why is this open? Close you. GDFO. Also, my dock. Does it like have separate tab lists? No. How does it structure it though? It's interesting. It structures it by some kind of thing I don't understand. Anyway, so movement.cpp. Now, if we think about the movement, what does the movement need to have? Oh, by the way, guys, I think we should do this now. I have to do it. Let me do that right now. I forgot to do it before stream. In fact, I remembered to do it, but I just kind of forgot. CMake. Is it just CMake mode? Hang on. Oh, don't tell me Elpa is not. There's not a bang Elpa. Wait, is there Melpa? always mistype stuff. Uh, okay. Okay. Yeah, I need to fix it because like Elpos should be on the bang list. Anyway, so the thing here that we need is CMake because I don't remember. Okay, it's a CMake mode. CMake will process with Emacs. I don't know what this is, but we need CMake mode. So we're just gonna type CMake mode, save it, and then space HRR to reload. Yeah, I'm sorry we have to take this time to install CMake mode, but it's just gonna be. Actually, now that I realize it's probably not required, but like still, it's better to have it now than like, oh, we're gonna do it next time, and next time never happens. So, I'm also really amazed, by the way, while that's loading. I'm really amazed by how Handmade Hero is. Okay, we have CMake mode. How Handmade Hero is just this thing where he explains the entire thing in like 5 minutes, and he just goes ahead and does the thing in like so in 10 minutes he's set up like he just starts coding. I spend like half an hour explaining all this stuff and like installing CMake mode midstream. But anyway, so if we look at this movement.cpp, um, how do you make a system? A system is just a function, right? So we are gonna need to create void. Usually systems are void, they don't return anything. Void um, movement, and I'm gonna put it under um, namespace. Um, should we name it sand? Let's name it sand. Sand systems. Yeah, system. Let's do that. And I'm gonna close this brace right here. So void movement. Um, let's look over here. If we go into ent, I think I clicked the wrong thing. I need their readme. Let's see here. How do they structure? So the system, it takes a registry. So really, any system takes a registry, but I am not sure if we wanna like pass a registry into every single function, because do we? Yeah, I guess so. I mean, it's not like we're gonna, yeah, I'm pretty sure we're gonna pass the entire registry. So, and the thing is that this is probably the ent registry. Do we pass it by reference? Oh, we do. Okay, that's it's not even an issue. Now, instead of, okay, let's do ent registry and then reference registry. And I wonder when I save it. Oh, okay. That's pretty good. Is this actual text? I'm gonna end you. Stop. I need to disable this thing where it, okay, but it's gonna add it anyway. I need to disable this in the LSP server. This is annoying. This is gonna be so annoying. Okay, so once we've done that, we obviously need to include, and this is one of the things I um, I kind of regret. about using the single include, because really the registry is defined in some one file. I'm pretty sure I can even find it real quick. Like it's, where is it? The include. I don't see include though. Oh, I think it's src slash end. No. Uh, registry. Hello. Yeah, I don't even know what the registry is. But point is, like, it's gonna be just like one file that probably defines this just one thing. But anyway, like, I don't think this is gonna cause issues. If it will, if it's gonna be like crazy load or compile time, it's gonna be fine. Also, I like the way that it is not putting namespace does not indent anything. That's pretty good. Um, but I really need to disable this. This is annoying. I'm gonna have to remove this because just no. I don't like comments, especially this kind of comment. This is just annoying. This is just plain like mockery. And so because we created this movement, we also need a header file under include. Now under include, if we are looking at this writing right here, ent.hpp, one of the things um, I'm probably gonna do in the include is I'm gonna probably create a directory called ent. There is a reason for that. The reason, did it create the directory? Where did you create the ent directory? Duh. No, wait, let's do this. Include ent. How do I, wait, how do I make it so that it would create? I don't want ent.hpp, I want this. Well, ent, jeez. Wait, can I not create? Okay, let's do it in this one and let's just move it up. But like, no, it's not copy one because this is .hpp. What? Okay, anyway, let's just move ent into um wait, can I not? What on earth? So move ent into ent, but like, oh my goodness me. So this is garbage. Seriously, this is just what on earth? What is happening? So is it here? Is it in there? No, this is the file. Okay, how do I there? So like what on earth is happening here? So we have components. What? Where? Where on earth is this thing? Okay, I'm gonna rename this to ent.hpp. This is cannot. How do I rename this? So this is a directory. This is another directory. I want to rename. Okay, let's rename this then. rename into int. Move failed. What on earth is happening? Ah, uh, what is happening? Okay, this is not very good. What is happening? Okay, okay, this is no panic, please. So, move and copy one into ent.hpp. This simple. This is what you had to do. And then what you need to do next is cd into component, and you need to do, let's see what's in here. You need to move this and blah 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 into just ent list. Now you move this ent dot dot cd dot dot ls, and you move uh, ent dot hp. Why is it that? Okay, never mind. That pp into ent, and then you cd, yeah, ent, and then you move this weird one into ent dot hpp, because that's what it's supposed to be. Now you do in the last, now you see the dot dot, now you do a tree. This is what I wanted. I wanted this and this. How hard can it be? It's a bug. What can I say? It's a bug. How hard? I'm gonna leave this terminal there. Although I'll probably move it like workspace too. It's just so it's not in the way. I'm about to make an argument that you should not use Emacs because Emacs like has this bug. But the good thing about Emacs is that Emacs you can fix it. Visual Studio or something, VS Code you okay, maybe VS Code you can, but okay, oh, I'm not gonna go down this rabbit hole of complaining about tools, because if this tool fails, I have a second tool. This never fails. Okay, almost never fails. But this is actually easier to use than this. Um, I hope that really quick command thing where I moved files, renamed them. MV, when you move a file, you basically rename the file. That's what's happening. So what I did is I moved this ent. I don't remember which order. I had to move from components. I need to move this ent up, then rename ent the HPP to actually be like what, not what it has become, but the actual ent the HPP, and move it into ent. It was pretty simple to do in the command line. It doesn't seem to be that easy to do in Emacs. So I guess I'm gonna use the command line next time, or just make it so that it would not do this crap. Anyway, so here we are then gonna need to change this to be ent slash ent.hpp. The reason why I'm doing this is because we are going to be having here a hash include sand slash components slash um, components slash, oh wait, that's not components, it's actually going to be systems. System slash movement dot hpp. And what are you doing? What are you doing? This is not gonna compile. this will not. How do you compile? Oh, it compiles because it's not in the path. So this is where CMake mode comes into play. This is what CMake files really should look like with the font lock and all of the features. So here, this is what I was talking about. The cool thing about CMake is that you just create a file and then you go system slash movement dot cpp. Now the reason that I call it system and not systems is because when you include, it's a little bit better to include system movement than systems movement because I don't know. I feel like that's better. Just my personal opinion. Anyway, now if we try to compile this, I mean, it's not gonna compile. And the reason, one of the reasons, is let's see, this is the beginning here. Also, does it have? Oh, nice! It doesn't have the previous compilation. Pretty good. One of the reasons is this, which I did not understand why so. Error. No such file or directory. Did I? I'm pretty sure I did. Oh, okay, it's down below there. DD, and then here, P. Wait, not here. Here, P. So order matters, as you can see in CMake lists. So we did not add. We added include directories after we tried to add subdirectory tests, which is why it failed. But here, the reason for that is because of this. Really? Oh wait, this is I guess it's messing it up with template. Okay, you know what? There should be autocomplete for this. There should be like include. Oh, okay, so I'm just gonna type include next time, like ink. I guess ink is what it's doing. Yeah, so you type ink. There's another version. There is ink C and ink H. Now, not sure what this is. Oh, it's just like, okay, it's just empty. I want to know what the ink H is. What is this thing? Oh, it's just like type here. Okay. Okay, that's pretty cool. Pretty cool, pretty cool. And so we need this one. We need sand because our game is a library, technically. Okay? Or at least the headers are kind of like a library interface. So it's going to be sand slash system slash movement.hpp, and there you go. So we have movement here, and that is that. We can save this file, we can rerun compile, and it's gonna tell me compilation terminated, no such file or directory. Okay, so now I actually want to test something. If you put spaces around here, would that still... Oh, it's not gonna let me. Oh, actually it does. Wait, I want to see it. Why did it fail? Oh, still. Okay, what if I put spaces in path? Wait, I need to know if that syntax that Emacs did, if that's even like possible to compile. Well, I know it's not gonna work, but I want to test this out. So we go into include here, and we here create a directory called system, and under system we create file movement.hpp. Now the reason why we create this file is because in here in movement.hpp we are just gonna say hash what I wait what's that? What if I put a hash? I can I put a hash, please? Okay. So we need pragma. I'm pretty sure. Okay, pragma once. I forgot exactly what the thing does. I honestly I don't remember. I just don't. But what we need here is okay. It doesn't have autocomplete for namespace. Well, there should be something. Namespace sand colon colon system, and inside of here you basically take this line and you just paste. Oh wait, you just paste it in here. That's all you do. That's all you have to do. Now I don't remember. We're gonna have to test it out. Um, okay, so this is not valid. Um, now I don't know which is not valid. So I believe this is still not valid. Yeah. Okay, so you okay, but what I'm just having fun, okay? This should compile. No, because I did not put it in under sand here because we need to go into include, create directory called sand. And now we have to move. Where is sand? There you go. This is sand. We need to move components under sand. Oh wait, what is it moving? Sand and system like this. So now under sand we have all of this. So I have int, we have sand. Now I'm not sure. Okay, it's just okay. Yeah. So this is not in the directory. I wish that these markers. I don't know. It's kind of hard to tell if it's in the directory. Like it looks as if it is. I think it should be more indented. That'll be yeah a little easier. Um, it already has a bunch of like weird stuff in here. Anyway, so we are done with this. So now when we compile, um, it's gonna tell me. So redefinition. The reason why it's saying redefinition is because uh, in the header file you put semicolon at the end, so you don't these what? No. Oh, you need to close this file because it's the system movements. This one, okay. So for this one, yeah, you basically put a semicolon here because this is going to be a declaration and the definition is in the CPP file. And we still need to include ent slash ent dot hpp, and that should work. Okay, it's gonna tell me that something I did incorrect. Hello? What have you done? Okay, this include formatting is gonna be a little annoying. But there we go. So running test on build and it passed. But the reason why it passed is because we didn't test anything. But that's fine because now under So we don't need the include anymore. We can close that. But under src, we're going to need to create a folder called uh, system movement. In fact, now that I think about it, this should have been a Google test. This isn't okay. I need to move this file then. Yeah. Okay, I did make a little mistake. Let's quickly move this into src/system. Okay, well it moved it the way that I didn't want it to. Let's move it again. System slash movement dot cpp. Where did the file go? Um, oh, you can't move because you don't. Jesus. Okay, I'm gonna have to like patch this up a lot because this is annoying. It doesn't know. Like I'm not. Okay, okay. I now understand. If you want to create a file, you better use Dired. If you want to open a file, you can use this garbage. This is mostly for viewing files, as far as I can see. It cannot even understand that I want it under a path. It just, like, honestly, this is annoying. Anyway, so let's close all of this garbage. And actually, under system here, let's create a file called movement underscore test. No, what are you doing? Movement test.cpp. And now if we open this, this is where the test will be. Now, if you look over at CMake lists here, we're going to specify test. And I'm not going to add the CPP extension because CMake is smart enough to understand that it should search for the extensions. It searches, I think, for C, CPP, CC, H, HPP, I think HH if that exists, also for object files. So you don't need to specify the extension. And part of the reason why you wouldn't want to specify an extension is because um, the intermediate file, like say .obj, will have main.cpp.obj, whereas if you specify the target as main, it's going to be main.obj. So that's the difference. But it really doesn't matter. If you have two files that have the same extension and they're not separated into like include and so you have the same name but different extension, and they're not separated out, well, okay, you might want to do something about that. Well, anyway, so movement tests. I forgot how to write these tests. You know what? I'm just gonna open up um, another Emacs. And I don't remember if I added this. No, I don't think so. So let me quickly navigate to tests, and I'm just gonna quickly remind myself how to do it. Okay, you write a test, you need to include gtest.h, and that's it. And then here you specify two parameters. Okay, yeah, pretty good, pretty good. It's pretty simple to do. So, can just modify this, yes. There you go. So we're gonna write a Google test. Now Google test is a macro that expands into a bunch of stuff. In fact, I'm not. If you read through the actual um, documentation on gtest, you're gonna find like what the thing does at the end. I'm not gonna do that though. So test, as I said, is a macro, and we're gonna put it under namespace sand systems. Oh, sorry, system. The reason why we're gonna do that is because does it know what the test should take? Oh, it's a macro. It doesn't need that thing. It's a macro defined in gtest. Don't you know? Okay, so the test takes two parameters. The first one is um, is the name of the suite. So that's going to be system underscore movement. Actually, you know what? Because we're testing the system, it's going to be system movement. Like I don't really know. Let me think about it. I mean, we are already here. How would we name this? You know, it's already in the under system. Let's do this. Movement. Um, and test. Actually, you know what? That's dumb. Let's call it system movement. The reason why I'm doing this is because I don't remember how it is displayed when the test is run, and I don't want to have something like send colon colon system colon system colon movement. Like that's gonna be dumb. So I'm trying to like remember what it was. What would be displayed like? So I guess we should just move on, and then we're gonna see. So system movement, and this one is gonna have a every test has like some kind of setup and then tear down. Now, in case of Google tests, you can write classes, and inside of this class, you like initialize everything and all that. We're not gonna do that though. We're just gonna go over to GitHub for ent in here, and we are gonna quickly peek at this file. So we are gonna need to create a registry, which is as simple as this. But for this registry, we're gonna need to include ent slash ent.hpp, and after this, we can create our ent colon colon registry. Now, something that would be cool if we didn't have to write this ent colon colon. I don't think we need to do that often though. So I'm not gonna use names. Yeah, we're not gonna write using namespaces like ent. No, we're not gonna do that. Okay, so ent registry, and let's call it registry. And after that, we're gonna need to create an entity first of all. And the way I need to close this thing because it's annoying. The registry. So you need to use this. So we're gonna create one entity with entity.create. Registry.create, and then we're going to do registry.inPlace position. Now we don't really have a position, but we will have a transform component. So under include sand components, let's create a file called um, transform.hpp. The transform is going to contain all the information we need about a certain entity. And in ECS, every component is a struct. So this is what you do. First of all, pragma once. Oh, this is how it's done. Well, no. No, I'm gonna use pragma once because I don't really care about it that much. I know that some compilers don't support pragma once, or some compilers are not. Like, I'm just gonna use pragma once, okay? That's what I'm gonna use. Um, it, I forget every time what it's doing. In fact, you know, let's just Google this thing. I forgot. Like, I need to know what it is because it has something to do with when you. There. I think it's this. Uh, preprocessor. Um, oh, how do you? What's a prag? I forgot what it is. I just like I need to know what it is. Yeah, so there it is. So it's basically, I don't know if you can see that. Let me zoom in just to make sure the character is readable. Basic pragma ones serve the same purpose as include guards, but with several advantages, including less code, avoidance of name clashes, and sometimes improvement in compilation speed. So it is better to use pragma once, but it's not standard, but widely supported preprocessor directive designed to cause the current source file. So I think you can define pragma once, like you can do a hash define or a dash d pragma once as hash if. Oh wait, the if def is gonna be. Yeah, I don't think you can do an if def on that. But like, it's basically like the include guard they have here. So like if I type once, um, this is gonna be the include guard. The idea of an include guard is this is how it works. So the compiler starts. Let's imagine this doesn't exist. The compiler opens the file, and it's like, is transform.h defined? If it's not, then basically it keeps everything that's in here. If it is defined, it does not include this block. Okay, this is how it works. Now, it decided to keep it because let's say this is the first time we open or include this file, and then looks okay. So we're gonna keep on. Actually, this is done not by the compiler; it's done by the preprocessor. So then the preprocessor goes like, okay, so next line here is hash define transform.h. What that does is next time this file is included, this will fail. This will not get executed, and any of the code that's in here is not going to be included again. So you put this at the end of the file and you write all of your code right here. This is where you write your code. Now, the the thing about this is that this is basically Pragma once. This is kind of what Pragma once does, but it's a little better. Pragma once is a little better in a way that Wikipedia described. Although I will admit, maybe it's not like a perfect solution. Maybe some compilers don't support it, but this point, most of the people who are going to compile this are going to be people from Microsoft Windows who will probably use Visual Studio Code, or sorry, Visual Studio. So they will use this Microsoft compiler. So that thing supports Pragma once. G++ supports it. I am pretty sure this other compiler that is pretty popular also supports it. So I'm not gonna worry about ifdef just because I don't like ifdef. Like, I don't know. I Yeah, I could, but like no. So anyway, this is Pragma once, and keep on going. We need to write a test, but actually we're not writing the test. We are writing the transform component. So component is a struct transform, and to always put a colon, semicolon there. And for the C++, sorry, for C people, I'm gonna also add type def. And type def tells me, what are you telling me? Type def requires a name. I think you, there you go. That should, okay. So the reason why we include this type def is because um, in C, if you have a struct and you intend to use it in like say inside of like say int main, like inside of here, if you were to create this thing, you need to type struct transform. But with this type def, you don't need this. You just type transform t, for example. So that's the advantage of type def. And we're going to try to keep it this way in our C++ code. Even though C++ does not require it, still, that will be interesting because then you can port to C easier. And in fact, we don't need C++ here because int, even though it's written in object-oriented approach, it is pretty much designed in such a way that you write code as if you were a C programmer because you almost never gonna write a class. You're gonna write a struct and a function. Maybe you will have a class, but that's unlikely. And if you have a class, you really should think about like, do I really need a class for this thing? So, now the thing about structs is, and by the way, int does support, like you can put a class inside of int's registry. You can attach it as a component, but I don't really see a reason to use that. Anyway, so typedef struct transform. This one is just gonna have integer, and the reason why it's integer positions, actually, mm, let's make it template. Oh wait, I think for this to work, yeah, I don't think you can do it this way. What's it complaining? Passive expected unqualified ID. I am just thinking, should we let's not do it this way. Let's just do here type def transform, and we're gonna use a u wait not a uint int 64t. And yes, I know 64t is not supported on 32-bit platform. It doesn't matter. Who cares? Actually, now that I think about it, maybe we should use long. Hang on. Let's see here. Mm, so I hmm I wonder um there should be I just need to know. Oh, there it is. I think it is. Oh, yes, 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 yes. Look at this. So, thing is, I still want to support 32-bit platforms, even though there's not used as much right now. So this here is signed. This is the fastest, which is what we need. Um, Smallest signed integer type with at least 80, 16, 64 bits respectively. This is the uint. Uint max, maximum width, unsigned integer type, unsigned integer type capable of holding pointer. This type needs to be available. Maximum width. Oh, I guess this is the one that we need. Int max t. Yeah. Yeah, we're not gonna use this. We're just gonna do Control Shift. No, Control OP. So int max t. The reason why I'm using the maximum is because it's gonna be better than doing like, long or something. Because, well, this is just foolproof, I believe. Okay, this is good. This is actually really good. Okay, int max t, x and y. For now, we're just gonna have two parameters here, and they're gonna be equal to 0, like this. And in fact, I would probably, yeah, autocomplete is gonna do this. What's it saying here? Unknown type. Because C std int. C std int. Okay, this thing is playing. Let me just click this and this. Okay, so C std int max t, x, and y. So that's gonna be pretty cool. And that is that. No type, no templates, no nothing, just int max t. And this is going to be specific to a machine or the architecture that we select. So we can pretty much do whatever. Pretty cool. So next up, once I have the transform, under test, so movement test at HAB, Okay, we're gonna need this later. What we need to do is we need to include sand slash component slash transform .hpp, and I do see that I need to rename this. Let's first close this thing. Rename component. Okay, and this is part of the reason why you write test first, because you see all of this like mistyping and all that. So here we're gonna in place a transform onto this entity that we just created. And here we're using this for loop, but I don't really need a for loop for all of this. I'm just gonna have one entity. Save every file. Okay, and let's in fact, you know what, let's group them like this. Register that in place, let's transform. And here, instead of this, let's in place a, let's see here, what might we need? Like, let's say put it at 0, 0. And by the way, we are gonna need to specify a constructor for this, which is gonna be transform Now that I think about it, I probably should make it lowercase like this. Or this. You know, let's keep it this way. Okay, transform. And this one will take int max t. In fact, doesn't really matter what type it takes. I mean, why? You know what? Let's make it take. Let's use enable if. Although now that I think about it, do we really want this kind of complexity? Enable if. I mean, I mean, let's see here. How do we use this thing? I forgot. Template bool B and class D. Enable it. Where do we? Yeah, this is what we need. Okay. I mean, this is an overkill, but like, who in the world cares? So type there x type y type enable if is integral x type valuable equal true. And actually, how do I make more than one? How do I make more than one? let's see, what is this thing? So like it takes a boolean, right? Yeah, it's a boolean b class t equals void. So um basically what we can do is, well, we can't really enable if std is integral type bool equal true. Um, let's do the same here. Stud enable if t stud. I don't know. This is kind of much. Is integral like so. Let me explain why I'm doing this. I want to be able later to pass in stuff into this that is not specifically an integer. It should be like a float or something, or like it doesn't matter what it is. And I want to be able to just pass it in, and I want to be able to like reinterpret cast it and just have that. Okay, is it correct? What is it talking about? Expected template parameter. Oh, it needs type name. And that stuff doesn't need type name, okay. And we also need to include um, type traits. This is kind of future-proofing your own design, you know? It seems kind of dumb. Um, I honestly don't think we need this. Okay, enable if here works. Here it doesn't, because it should be a bool. Now this should work, but it's saying um, no template named. Enable if. Okay, so now it works. But like, that's a lot, you know? So this will take um, x type x, y type y, and we'll sign x with x, y with y, and that is literally it. That's all we need. But I'm not sure if this is like what I want to keep here, because it does feel to me like I'm just future-proofing my code, and it seems kind of valid, but at the same time, not really. I mean, yeah, it looks horrible to be honest. Also, we can't just put it in there. We need to do a reinterpret cost, I believe, which is why I'm just gonna search cost, and there's like a bunch of them. Look, static cost, dynamic cost, static pointer cost, any cost, um, what is it? Duration cast, reinterpret cast. So I'm just gonna do a reinterpret cast because I think this is the one. Unlike static cast, but like const cast, the reinterpret cast expression does not compile to any CPU instructions except when converting between integers and pointers on an obscure architecture where pointers representation depends on type. It is purely a compile term direction which instructs the compiler to treat expression as if it had the type new type. Uh, Only following conversions can be done with interpret cost. Let's see. Um, where is this thing where they show? I think it's not dynamic. I guess this. Mm, um, okay. Is there a list of all of the? No? Okay, so I guess we need a static cast. Let's see. Converse between types using combination of implicit and use defined conversions returns a value of the new type. Okay. Uh, Only the following conversions can be done with a casting except for such. Okay. So if there is an implicit conversion sequence from conversion. Okay. Say we're colors falling on the line that another two of us are gonna die. Yeah. Dun, 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 dun. Let's look at the examples. It seems like we need to use static cast, but okay, let's use static cast. Feels like reinterpret cast is more like a pointer thing. Okay. Yeah, there you go. So with this, we can now try and compile. And not sure what it's saying here. And let's see the error. Oh, there's quite a few. First one is I percent. Okay, yeah, this is from main.cvv. Let's get rid of this. And this is honestly not really required. Also, I don't know what this is. Probably from an if statement. Oh, this is the end of the function. Let's see how this goes about. Error invalid cast from type int to type int max, aka long int. Did I type reinterpret cast? Didn't I say I'm gonna use static cast? I mean, let's try this. Oh, there you go. So we have one test and the test passed. So this is what we need to do. We need to use static cast. And the reason why I wanted to do that is because, well, I just wanted to test if we can put all sorts of weird values in here. So let's use this transform dot in place onto this entity, and actually, um, no, we're not gonna do that. Okay, so that's pretty easy to do. So that's what probably, I mean, I don't know, but we should be able to create a transform component with all sorts of values. Now we're not gonna write a test for creating these all sorts of values. Oh, sorry, got distracted. So back to what I was saying. Uh, we're not gonna write a test for it because if we would ever need to compile with this template nonsense actually being used, we're gonna know if it works or not. So for now, let's keep it this way. Um, now, we'll admit this is overkill, but it's fine. Um, Next up, once we do an in place, we need to apply some movement. Now, the movement is going to be done by another piece of thing, a um, piece by another system. Now that I think about it, so the transform holds position, okay, a position of a specific component, and the transform, as far as I understand, should also hold the acceleration and the rotation. So I personally, the way that I would handle acceleration, because of the way that, it's just going to be easier for me this way. You know what? Let me think about it. Instead of, mm, I mean the move. So here's the thing I want to do. I want to handle current velocity and acceleration as it should they should have multiple forms. So they're gonna have um, I think it's called a normalized form. Basically, the way it would work is we're gonna imagine. I'm gonna need a GIMP for this. I can't explain without this beautiful tool. So, like, let's create a new file. So imagine you are standing here, and you want to go. Um, you want to go here. So how would you emulate this movement? Well, what you can do, let's choose black for actually let's choose some beautiful color. So let's say you want to go here. The way that you can do this is you can say that currently velocity is equal to 0. I'm going to apply, I think there is a way to draw a straight line. There you go. I'm going to apply this vector, which basically has like a certain length, and over here imagine this is our this is x-axis, or better say, this is not really x-axis. This is like our axis something. Doesn't matter which one, like some kind of axis. We can measure this angle in some degree, and we can say, and so this is going to be L. So let me grab actually a text thing. So this 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 like velocity or acceleration or whatever it is doesn't matter. It's basically a force that we apply, and we can say that position after movement, so position 1 equals um, position 0, and this is going to be also, it's going to be like position 1 on the x coordinate. um, how do I, let's do it this way. So position, so new position, let me write it as code. Oh, accidentally clicked caps. New position on axes. Let me make this smaller so you can see a little better. So new position is going to be old position. How do I move this? I guess that's going to be how I'm going to move it. I'm not really that bothered with the fact that I'm doing a mess. Let's move it over here. So our new position is going to be old position on the same axis, um, plus or minus. It could be minus, but the thing is, if so you add, and then it's either sinus or cosinus. I don't remember which one. I think it's gonna depend on which axis you. Actually, no, it doesn't depend on that. Basically, it's gonna be either a sinus or a cosinus. I don't remember of um of this alpha, which I'm gonna draw like this, times length of this vector. So this is going to be the function. The good thing about this sort of representation is that now alpha is a value between 0 and 1. 0 being oriented just like straight forward or whichever way, it doesn't matter. Uh, 1 also means oriented straight forward or backward. But the thing is, we'll never have a alpha equal to 1. It's always going to be like 0.9999999999999, and then if you increment a little bit more, it's just going to be 0. So because it's just going to loop around. So that's going to be pretty cool. We can also represent it in degrees, so we can have 360 degrees, but it's pretty easy to calculate the amount of degrees just by basically multiplying this floating point number 0.5 by say 360. Bang, you get the value in degrees. Um, and then you can also do you can also measure it in oh, we're not going to do that. So it's going to be radian. Actually, wait, I think in radians the maximum is um, I think it's 2 pi. So actually the max, oh, actually I forgot, you know? Yeah, actually I forgot. I need to look up this math, how it works. But point is, you basically plug in here a number. This gives you some um, some like coefficient, some multiplier that you then multiply the length, and this will give you. Let me show you what that gives you. Let me make it. I don't know, like some kind of. Um, let's make it green, green and bold. I know it's hard to see. I hope you can see something. That green stuff, I'm not really sure if it's a sinus or cosinus, is gonna be, let's say this way, this way is x direction, and we're calculating it for the x direction, so this is x. This green term is gonna give us this. So from here until here, so it's gonna give us this distance. And that is also calculatable for the y coordinate. But then for the y coordinate, I think you use the opposite. You instead of sinus, use the cosinus. I forgot all of this math, to be honest. But I do have a cheat sheet somewhere, which is a physical cheat sheet, and I cannot find it now quickly, I believe. Let me see if I can. I should be able to. It should be somewhere nearby. Let me see real quick. No, not up there. I really need a cheat sheet right now, by the way. If I knew we are gonna do physics and math, I would have prepared a little better. I don't see the cheat sheet though. Okay, forget about it. I'm gonna find it later. So point is, the reason why this math works is because if you look at a triangle, let's make a triangle right here, and let's specify, I don't know, 1 pixel. This is annoying. So let's say we have, okay, wait, no, not 1 pixel. That's also annoying. Let's do 5. Yeah, this should be better. So if you look at a triangle, let's say this is a nice triangle without this jagged edge. This angle here is 90 degrees, and it's this. Let me. There you go. It's 90 degrees. This doesn't matter which. You could mark this one. This is our alpha. This is what we had here. This is our alpha, so you can kind of draw like a, sorry, like this rectangle, sorry, triangle here, or you could have drawn it this way. It doesn't really matter. Point is, this is alpha. In this case here, the alpha is actually on the other side. So you can kind of think of it as, kind of extending it this way and being here. And the reason why these two are equal is because this is 90, this is 90, all of them are 90. And basically this here, this is 90 minus this. So like this angle, how do I, there's black stuff that I marked. This is 90 minus this one, the alpha. And then this is 90, so 90 minus this is alpha, so this is alpha right here. So back to our triangle right here on this small piece of not even paper. So if you look here at this alpha, then you get this here. This is our L. This is the length of our vector. This is our origin point. This is like, you would probably say this is like 0, 0. It's pointing that away. I cannot draw an arrow today. And okay, this is horrible. This is worse than I could have ever drawn. Let's do it this way. So it's pointing that away, and this, say this, doesn't matter which one. This is X. This is Y. Now you could swap them. Doesn't really matter. And essentially, the way that the triangle works is if you multiply L by sinus or cosinus, I forgot which one, then you get this side. Now let me remember. Oh, I forgot. I think cosinus is x and sinus is y. Uh, but I might be mistaken, which is why I'm just gonna Google this thing. Um, right triangle. What is it? Cat. Is it? Anyway, sides links. And we need the formula. We don't need the calculator. We need the formula. So we click on images because usually images in this math stuff it will have more information. And so where is that formula? Where is that thing? This? Where is the sinus cosinus? Where is the sinus cosinus? Maybe here? No? No? Where is the... Okay, let me just... I'm sorry, I don't remember how to... I don't remember this math, it's been so long. But it's pretty simple math. Honestly, I want to go back to school. Wait, that's not what I want. So, the reason why I'm not... I just... You see, I don't want... Oh, wait a second. This doesn't... This does not have the answer. Hang on. How do I... Where is the formula? Wait. Hang on, I think I should just Google formula. Oh, there it is. So this is the set of formulas that you need to remember. Wait, I opened. Okay, yeah, that'll do. So this is the formulas that you need to remember if you're going to be doing this kind of velocity thing. So here they describe that sinus. I forgot that they exist. So sinus is opposite by hypotenuse or I forgot. I don't know how to pronounce this thing. I'm gonna call it hypotenuse. So this is A divided by C for sinus of alpha. And alpha, the way the markings on the triangle work, if you forgot from school or your school taught you differently, the way we were taught and the way this is laid out is A, lowercase a, is opposite of uppercase A. And in this case, the uppercase A, it's not, it should be alpha, in fact. But they can't put alpha in this text for some reason. So basically, this should be alpha. So alpha is this angle here. So A is opposite of the point A and opposite of angle A. So in this case, the sinus of any angle is opposite side. So that's going to be the same letter as the angle letter over here, divided by C. C is the hypotenuse. I don't know how to pronounce it. And then sinus B is going to be B divided by C. But we don't need to confuse ourselves with sinus B. Just imagine this does not exist. We are only interested in this. So, and also tan. I'm not really sure if that will be interesting to us. I forgot. Oh, actually, okay. Uh, we might, if we need to find one of these from the other, yeah, okay. So we're not gonna focus on this for now. We want to know what would be, say, like let's just imagine that this is x direction and this is y direction. we have c, and we have the value of sinus and cosinus because we can calculate it with C++. So we can say like sinus of some angle, and it will tell you like, I don't know, like zero point 0.5, for example. I think zero point 0.5 is for 30 degrees. I don't remember. I think it is. I need the cheat sheet because the cheat sheet had like a shit ton of stuff. Hang on, is it like literally here? No. Oh, this. Oh, you really do need this thing because that had everything on there. Hang on. Is it that? No. Um, hang on. I know it is somewhere, and I will need it now that I think about it. Okay, I think I put it away and I forgot where I put it. That's embarrassing, but I really do need this thing. Yeah, I can't find it. Okay, anyway. The cheat sheet had all the math formulas in one place, and when somebody was like, "Oh, do you want this like school cheat sheet thing?" I'm like, "Yes, sure. I'm gonna be doing game dev. I'm gonna need this thing." Um, in fact, you know what? I might even there should be there should be like algebra. Wait, algebra or is it geometry? I think it's wait, algebra cheat sheet. Should be this one. There just should be. Yeah, there it is. So I'm talking about something like this, where it has all the formulas, except this is algebra. We need geometry. I yeah. I have one for algebra and one for geometry, and there is like a lot of stuff in there. And what's really cool about these cheat sheets is that you just look at them and you just look at them and you just write code based on what they say. You don't have to think. You don't have to think. Okay, so um, this is not quite what I'm looking for. Wait, do I still have the book? Hang on, one sec. I had just realized that when our school threw away a bunch of books, I took a few because I'm like, dude, this has like formulas and stuff. Maybe it's not from that. Yeah, actually, these are not from there. But anyway, do not throw away books. Why would you throw away books? I mean, what is the point? Like, they are in pretty good condition. Maybe it's the one. I doubt that I purchased this one, but I might need to. Anyway, this one should have like sinuses and stuff. Oh, it has volumes. Oh my god. Looking at this. Yeah. Oh, what? Okay. So how would I approach this says geometry, but it's most oh wait, that's 11th grade. Oh, I think we need 9th grade for this one. And I have 9, so I have 11th grade and 10th grade, but I need 9th grade because this is like 9th grade stuff. Because that's when that's sorry, that's where. Also, did I glue this in the wrong way? Oh, they surely did. So the thing that I cannot show to you on camera because I don't have a camera, but the way they glued um, the pages with the formulas on one side of the book, it's the normal way. When you flip it over, it's upside down. How? How? Yes, 0 0.5 is sinus of 30 degrees, and the cosinus of 60. Yeah, cosinus of 60 degrees. But this, okay, so I found the thing that I was searching for. I found some formulas. So actually, okay, no, that's not important. Oh, wait, interesting. Okay. Um, let's see here. So we need the formula that I do not see somehow. Somehow I do not see the formula. Probably because it's on the other side of the book. It's on the side that's glued incorrectly. The correct, the correct side. So I'm not sure why am I still looking at this because I already have the answer. Uh, Also, it's pretty boring in here because nobody's in chat. Okay. Um. Yeah, this one doesn't. Yeah, we need nine's great book because this one's just useless. Okay. Well, anyway, we found this. And I'm gonna write this down inside of my Scratch document because I will need this later. The reason why I'll need this later is, let me just kind of, where do I, let's just put it here. So math cheat sheet. I'm gonna, oh wait, you don't need this, you just do slash um, begin equation slash end equation, and here in between you put that. Oh, you can't draw, I believe. I don't think you can draw. Hang on. LaTeX, draw, triangle. I mean, there should be something there in LaTeX. Let's see. There should be a package for it. I wanted to draw, yeah, this triangle. This is basically what we need. Probably. Don't know tick is more than you. Being a MetaPost user. But in case I just consolidated quite an elegant tutorial at the beginning of its documentation. I've come to this result. Oh, nice. Let's just do Control C, Control OP, document class. Okay, I don't think we need this. Use package, yes. Begin document, go away. Begin, take his picture. Draw some nodes. I don't know what this, oh, this dash cycle. Take his picture. This should, please, really. No. Is it because I put in the wrong one? Yeah, kinda. Use baggage. Oh, is it Tiggs? Yeah, it's Tiggs. Mm, it's almost as if we need to paste in all of this. Okay, you know what? Um, I I am not very much impressed. I mean, let's add org mode. I just want to like actually write the documentation for it, which di well, I mean, not really diagrams, you know. I'm not asking for diagrams. I'm asking for like, okay, you know what? Let's not do. Okay, let's just abandon the triangle. We know how this works. We just need sinus. Let's do it this way then. Let's just do it this way. So we're gonna have a begin equation, end equation, and here we're just gonna say um, sinus alpha equals um, fraction. So opposite. This is LaTeX, just for those of you who don't know. By hypotenuse equals fraction. This is gonna give us some nice formulas. So A divided by C. So this is gonna be what it's gonna look like. Basically, the same thing as this. I'm just kind of copying them. And the reason for that is because I will need to consult this document. I don't want to search for this stuff again. So cosinus is going to be pretty much the same. except that this is adjacent. There you go. Okay. It would be nice to have a graphic of this as well, but that's fine. So with that, um, we can now make a decision on, let me just see, so radiance, let's do 2 degrees formula, maybe that should give me times pi divided by 180. Let's see, 120. Okay, hang on. Let me just do this. Radiant 2 degrees. There should be a calculator. I need to know how much is 360 because I forgot. Okay, so that's gonna be 2 pi. So in that case, 180 is gonna be pi, and 1 degree is gonna be this much radiance, which is gonna be kind of interesting to implement. So I just want to make sure I have that in my cheat sheet. So radians to pi equals 360 still doesn't have degrees. How do I, is it just deg? There. Okay, that will do. Um, all right. So from this, we can convert, but we're not gonna do this right now. Okay, so I would say that we should take a break. Come back to this later. Um, so I'll be back a little bit later. I'm not sure when, and if it'll be even today, but someday and sometime. So, see you later.